I welcome you to my YouTube channel. In this video, I'm going to teach you two JEE questions from solution lesson. Let's see the first question. A solution which contains 10 gram of electrolyte AB2 dissolved in 100 gram of water. The solution boils at 100.52 degrees Celsius. The data is given are AB2 molecular mass is given as 200 gram per mole, and the boiling point elevation constant, the Kb value, is given as 0.52 Kelvin kilogram per mole, and the normal boiling point of water is given, and you are to find out what is the degree of ionization of AB2. You have to express the answer in terms of 10 power minus 1. So this question was asked in JEE mains. Let's see how to solve this. First, we'll have to calculate the molality of the given solution. So to find out the molality, the formula to be used is mole of solute divided by mass of solvent. Here, to find out the moles of solute, here the 10 gram of solute has been given. Molecular mass is 200 gram. And then we are dissolving it in 100 gram of solvent. So in terms of kilogram, zero point 0.1 kilogram it comes. So if we simplify it, so the molality of the solution we found to be 0.5 mole per kg. So the next thing what we need to do is by using elevation boiling point formula, delta T can be calculated by using I into Kb into M formula. So here in the question they have given the solution boils at 100.52 degrees Celsius. 100 is boiling point of water. So the difference in boiling point is 0.52. Then by substituting the value, we'll have to first calculate the I value. Because Kb value is given in the question, we calculated the molality of the solution, and then since it is a Ab2 type salt, it undergoes the dissociation. We need to calculate the I value. By rearranging this formula, I will be able to calculate the I value to be 2. Then we need to relate the Van't Hoff factor. So we know that this Ab2 salt undergoing dissociation into A plus 2 and 2B minus. So this formula it's known. If you want to find out alpha of dissociation, we know that I minus 1 divided by N minus 1 formula. By rearranging this formula, we'll be getting this. Here, you'll be getting 1A plus 2 and 2B minus. In total, you will be having 3 ions. So in the place of N, you can substitute value 3, and what we need to do is when you simplify this, you will be getting 1 plus 2 alpha, and then in the last step we calculated the value of I to be 2, and then in the place of I am going to substitute the value 2, and then by rearranging this I will be able to calculate the alpha value to be 0.5, but the answer has to be expressed in terms of 10 power minus 1. So if you move the decimal point to the right side, I will be getting 10 power minus 1. So the answer is 5 into 10 power minus 1. Let's go to the next question. X into 10 power minus 2 ml of methanol is being added with 100 ml of water. The freezing point drops from 273.5 to 270.65. So the graph is given. From the graph I have converted the data. Here is the point, freezing point of the water. So freezing point of water is 273.15, and then here is the point, freezing point of the solution. The point is 270.65. The molar mass of the methanol is found to be 32 gram per mole, and the density of the methanol is 0.792 gram per centimeter cube, and the density of water is known. It is 1 gram per centimeter cube, and molar freezing point depression constant for water is given in the question. Kf value is equal to 1.86 Kelvin kilogram per mole. So this question was asked in JEE mains. The value has to be expressed in terms of 10 power minus 2. Keep that in mind. We'll have to first calculate what is the depression in freezing point. To find out that, we know that the freezing point of the solvent. So TF naught minus TF will give you 2.5. So 2.5 Kelvin is the depression of freezing point. Next step, what we need to do is by using delta TF is equal to I into KF into M. So here I values 1. Here we need to know what is the molality. So molality values are not given, but only the uh, mass of the solvent is given. By using density, we can convert the volume into mass. So this is your point 1. So delta TF value is found here 2.5, and then KF value is given in the question 1.86. And then in the place of molality, number of moles divided by mass of the solvent. So rearranging this equation, we'll be getting the N value, the number of moles, to be 0.1344. So then next thing what I need to find out is by using this formula, weight is equal to number of moles into molar mass. Number of moles, just now we have found it. The molar mass of the methanol is 32. From this we calculated the mass of methanol to be 4.3 grams. Then we'll have to calculate what will be the volume of the methanol. So methanol is a liquid. So we have calculated the mass of the methanol. So to calculate the volume, we are going to use the formula volume is equal to mass by density. So mass of the methanol is 4.3, and the density of the liquid is given to be 0.792. So we have calculated the volume of the methanol is 5.43 ml. But the answer have to be expressed in terms of 10 power minus 2. So I'll have to move the decimal point 2 places to the right side. So I will be getting answer as 543. So this is your answer. Thanks for watching.